Hey guys, welcome back to Math Principles. So far, we've been talking about solving linear equations and using linear functions and applying systems of linear equations. Now we're going to get into polynomial equations, and we're going to start with quadratics. Now, a quadratic function is anything where the highest exponent on x is 2. So if it has x squared and it doesn't have cubed or raised to the fourth, that's a quadratic. There's a couple different ways that we can solve quadratic equations. Probably the easiest one to start with is factoring. So that's what we're going to start with here. Now, factoring a quadratic function or equation starts with ax squared plus bx plus c and gives us an equation or an expression that looks like this. A sub 1 times x plus c sub 1 in one set of parentheses times a sub 2x plus c sub 2 in another set of parentheses. So we have two linear factors getting multiplied together. So the question we always get is what happens to the x squared? Well, it didn't disappear. This is reverse foiling. If you remember back from probably algebra 1 or maybe even pre-algebra, when you multiply two linear factors together, you have to foil. You have to multiply the firsts, the outers, the inners, and the lasts. Well, if you multiply the firsts together, this x times this x is going to give you that x squared. Okay. Now, the outers and the inners are where most of our factoring takes place. Okay, so I drew this out for us where I have this little smile down here, and that's O for outer. And I have this little smile down here, and that's I for inner. So I'm going to refer to those as the outers and the inners, and I need to make sure we understand what we're talking about there. So here's the trick that we come up with. Okay, this chart right here will help you factor any quadratic that can be factored. Okay, what it all comes down to is C, this constant term that's all by itself. If C is positive or negative, that tells you pretty much everything else you need to know about how to factor. Now, these two numbers here, they have to multiply to give you C. Okay, so if these two multiply to give you C, and C is positive, your outers and your inners are going to add to give you bx. If your C term is negative, your outers and your inners are going to subtract to give you bx. Now I have O minus I. It might be the other way around. It depends on this next bit. Now, if C is positive, both of your factors are going to have the same sign as bx. So if B is plus, excuse me, if C is plus, both of your factors are going to be plus if B is plus, or they're going to be minus if B is minus. If your C term is negative, well, in order to multiply these two together, to get that negative C, one has to be plus and one has to be minus. The catch is we don't know which one's which until we put the numbers in. The larger outer or inner will get the same sign as BX. Now, we can refer to this chart anytime we need to. Let's take a look at a couple examples. Now, this is kind of a good news, bad news scenario. The good news is factoring can get really, really easy after a while. The bad news is it takes a little bit of time. It takes practice. It takes a lot of examples. So we're going to look at a bunch right now. Let's get right to it. First one I have is x squared plus 7x plus 12. So I know that I'm going to need two sets of parentheses. I know those parentheses are both going to start with x. Then we think about that chart and remember that everything comes down to this C term. So my numbers that I'm going to use here are going to have to multiply to give me that 12. So I like to list those options. So I've got 1 and 12, 2 and 6, 3 and 4. And I can use these in any order that I want, but I have to use each pair. I can't mix and match. Okay. Now, because my C term is positive, I know that both of these factors are going to get the same sign as bx. So I know before I even put the numbers in, I know that these are both going to be plus. They're both going to be that same sign that bx has. Next up, I need to pick a pair of these that when I sub them in here, they add to give me 7x. So let's just try trial and error and see what happens. Okay, I've got 1 and 12. So on the inside, I'd get 1x. And on the outside, I'd get 12x. Okay, well, I can't add 1x and 12x and get 7x. So this one, no good. Okay, next up, let's try 2 and 6. Now, on the outside, we would get 6x, and on the inside, we would get 2x. Now again, we have to add these together. 2x plus 6x does not give me 7x. So that only leaves me one other option, and that's 3 and 4. So we'll get these out of there, and we'll try 3 and 4. Okay, and we'll check. On the inside, we get 3x, and on the outside, we get 4x. And if we add 3x plus 4x, we do get 7x. So this is the factoring that we want. Now, the point of factoring, what this does for us is it gives us two linear factors instead of x squared and regular old x. Everything is just regular old x. This will help us do some other stuff later on. Right now, we need to focus on just doing the factoring itself. So let's take a look at the next example. We have x squared plus 5x plus 6. Okay, so I know I'm going to need two sets of parentheses. I know those parentheses are each going to start with x. Okay, these first terms need to multiply to give us that x squared. Now, the numbers I'm going to put here have to multiply to give me 6. So I've got 1 and 6 and 2 and 3. Those are my options. Now, because my C term is positive, I know one of these is plus and the other's minus, but I don't know which one's which until I put the numbers in. So let's try. Let's try 1 and 6. Okay, on the outside, we'll get 6x. On the inside, we'll get 1x. And I need to be able to subtract those to get 5x. Well, if I do 6x minus 1x, that gives me the 5x that I need. So the catch is the larger outer or inner gets the same sign as bx. So these are the right numbers. Now I need to figure out the signs. Well, 6x is bigger than 1x, so this gets the same sign as that 5x. So this one has to be plus 6x, and this 1x has to be minus. So the minus goes with the 1, the plus goes with the 6, and we're factored. Okay, let's take a look at a couple more. X squared minus 10x plus 25. Start out the same way. Two sets of parentheses, x and x. Okay, now I know that the numbers that I'm going to use need to multiply to give me 25. So my options are 1 and 25 or 5 and 5. Okay, well, I also know that my C term is positive, which means both of my factors get the same sign as that bx. So since that's a minus 10x, these are both going to be x minus. Okay, and I need numbers that are going to add to give me 10. Well, I can kind of stop with the guess and check a little bit and stop writing it at least and just kind of do it in my head. If I do 1 plus 25, that doesn't give me 10. But if I do 5 plus 5, that gives me 10. So I'm going to try x minus 5, x minus 5. Now, even if you're pretty confident, you should still try and make sure that it works out. Okay, so on the outside, we'd get minus 5x. On the inside, we'd get minus 5x. Now, because my C term is positive, I need to be able to add these two and get minus 10x. Well, minus 5x plus minus 5x, it gives me that minus 10x. So this is the right factoring. And we can move on to the next. Okay, so let's take a look at the next one. We have x squared minus x minus 56. So the first thing that we know is we're going to have two sets of parentheses, and they're going to start with x and x. We know that those first terms need to multiply together to give me that x squared. Next up, I look at that c term, and I know that I have to use numbers that multiply to give me 56. So I've got 56 and 1, 28 and 2, 14 and 4, 7 and 8. Okay, now because my C term is negative, I know one of these is going to be plus and the other one's going to be minus, but I don't know which one's which until we put the numbers in. Well, I also know that those numbers need to subtract to give me that minus x. Well, I'm going to say minus 1x. Okay, so what I can do is look at each of these pairs of numbers and see which ones have a difference of 1. And that's probably going to be the one that I need. 56 minus 1 gives me 55. 28 minus 2 is 26. 14 minus 4 is 10. 7 minus 8, that's the negative 1 that I need. So this is the pair of numbers that I'm probably going to use here. So let's look at 7 and 8. Okay, now always check. Even if you're really confident, make sure you check your outers and your inners. On the outside here, x times 8 is 8x. The inners, 7 times x, is 7x. Okay, now I want to see if I can subtract these two to get that 1x. Well, 7x minus 8x in that order gives me negative 1x. Okay, and that's exactly what we need. Now, the larger outer or inner gets the same sign as bx. Since 8x is bigger, it gets the minus, 7x gets the plus. So that means it's got to be x plus 7 and x minus 8. And now we're factored. Now, all the ones we looked at so far started out with x squared. What happens if it doesn't start out with x squared? Maybe I have 11x squared or 2x squared. Well, there's some things we can do in this venue as well. Okay, the first thing that we can try is factoring out a GCF, a greatest common factor. So if I look for something that divides 11, 77, and 66, I can see that they're all divisible by 11. So I'll bring out an 11, open up one large set of parentheses, and divide that 11 from each of these terms. Well, 11x squared divided by 11 gives me x squared. 77x divided by 11 gives me 7x. And 66 divided by 11 gives me 6. Now, I can leave the 11 out front and factor what's left. Okay, well, now I have that x squared, so now I know these two sets of parentheses need to start with x. Okay, then I look at the c term, which in this case is now 6. Okay, once I brought out that GCF, we're focused on this quadratic right here, not the one that we started with. So I look at my factors of 6, and I've got 6 and 1, and I've got 2 and 3. Okay, and I need a pair of those that's going to add up to give me that 7x. Well, 6 and 1 seems like the one to go with. So I'll put in 6 and 1. Since my c term is positive, I know that these are both going to have the same sign as bx, which is plus. And then we'll check the outers and the inners. On the outside, x times 1 is 1x. On the inside, 6 times x is 6x. Okay, and because my c term is positive, I need to be able to add these. 6x and 1x gives me that 7x that I need. So this is the correct factoring. And notice that that 11 is still out front. GCF stands for greatest common factor. So it's part of the factoring. It needs to be part of our answer. Let's take a look at number 6 here. Okay, let's start out the same way. I see 2x squared plus 12x plus 10. And my first thought is, well, let's see if we can bring out a GCF. So I think that these are all divisible by 2. So I write down the 2, open up one large set of parentheses, and divide each term by 2. 2x squared divided by 2 is just x squared. 12x divided by 2 is 6x. And 10 divided by 2 is 5. Now, this is the one that I'm going to factor. Okay, these numbers, they're not as important anymore. Okay, so I'll leave the 2 out front, 2 sets of parentheses, and to get x squared, I know they both need to start with x and x. Now my c term is still positive, which means that both of these factors are going to have the same sign as bx. So they're both going to be plus. Then I need numbers that multiply to give me that 5. Okay, well, the only options that I have are 5 and 1. Well, let's check. Even if those are the only options we have, we should still check. Okay. On the outside, we get 1x. On the inside, we get 5 times x is 5x. Now, because our c term was positive, you guys can see that because of the glare, okay, our c term was positive, we need to be able to add these two to get that 6x. 5x plus 1x gives me that 6x. So this is factored, this one's done. Okay, now in the next couple, you might notice we can't take out a GCF. If I try to divide everything by 2, nothing divides by 2 except for that first term, which means I'm stuck with that 2. Well, this can still be factored. We'll start out with 2 sets of parentheses, same as always. Now the catch is we always knew that we had x and x because x times x gave us that x squared. Well, now I need something that'll multiply together to give me 2x squared. How about 2x and x? 2x times x gives me that x squared. So your firsts still need to multiply to give you that first term, okay? That hasn't changed, but what that first term has become, or excuse me, what that first term is, has changed. So all the other rules are still in place. Let's follow them. I need numbers that are going to multiply to give me that 3. So my only option here is 1 and 3. Now the question is, where are they going to go? My C term is negative, which means one of these has to be plus and the other one has to be minus. I don't know which one's which till I put the numbers in. So let's try. Let's try 1 and 3. On the outside, I'll get 6x, and on the inside, I'll get 1x. Now, if your C term's negative, you need to be able to subtract your outers and your inners to get that bx. Well, 6x minus 1x gives me that 5x. So these are the right numbers. They're in the right place. We can go ahead and put the signs in place. Now, the larger outer or inner gets the same sign as bx. So since 6x is bigger than 1x, it's going to have the plus, and 1x is going to have the minus. So we'll have 2x minus 1 and x plus 3. And there we go. This one's factored. So putting a number in front of that x squared doesn't really change anything. We bring out a GCF if we can. If we can't, we just work with it. Okay, let's take a look at number 8 here. Number 8, I've got 3x squared plus 10x plus 3. Now my first thought is I could divide these two by 3, but we need to be able to divide the entire expression by 3. And since this 10x is not divisible by 3, I can't bring out a GCF. So go to my 2 sets of parentheses, and I'll use 3x and x, because 3x times x gives me that x squared. Now, my C term is positive, so I know my 2 factors are going to have the same sign as bx. So they'll both be plus. Now I need numbers that multiply to give me 3. And my only options are 3 and 1. The question is, in which order do they go? Well, let's try them. On the outside here, I would get 3x, and on the inside here, I would get 3x. And I need to be able to add these two to get that 10x. Well, that doesn't add up to give me 10x. So let's try reversing them. On the outside now, we have 9x, and on the inside, we have 1x. 9x plus 1x gives me that 10x that I need. So these are factored now. Now let's take a look at one special case for factoring. It's called the difference of squares. So difference means subtraction, and squared, well, x squared. So if I have a squared minus b squared, this is the difference of 2 squares. I have 2 squares being subtracted. And it has a special way that it factors. If we can recognize the case that we're in, we can jump straight to this, okay? And the special factoring is a plus b, a minus b. Okay, now the catch is we have to recognize what's being squared for a and what's being squared for b. So if I have x squared minus 9, the kicker is, there's no regular old x term. There's just x squared and a constant. If we recognize that, we're pretty much guaranteed it's got to be the difference of 2 squares. So what we do is identify what a and b are. A is what's being squared to give us this guy. Well, I would square x to get x squared. B is what's being squared to give us this guy. Well, to get 9, I would square 3. So this will factor x plus 3, x minus 3. And that's it. Okay, the tough part on these is recognizing what a and b are. Once you identify a and b, the rest is a walk in the park. So x squared minus 49. Now I notice that there is no regular old x. There's x squared and there's minus 49, the constant. There's no x term. So this has got to be the difference of two squares. So I need to identify what a and b are. Well, to get x squared, I would have to square x. To get 49, I would have to square 7. So this one's going to factor x plus 7, x minus 7. And there we go. Now, if we want to check this following the old rules, okay, our c term is negative, so we know one's got to be plus, one's got to be minus. We know the numbers need to multiply to give us that constant term. Well, 3 times 3 gives me 9, no problem. Okay, and we know that these terms need to subtract, excuse me, yeah, they need to subtract to give me that b term. Well, there is no b term, so that bx would have to be 0x. And if I do, on the outside I would have negative 3x, and on the inside I would have positive 3x. If I put those two together, that gives me that 0x. So that old chart still works, but if we can recognize the difference of squares, it's going to get the job done a little bit faster. Let's take a look at this next one. 16x squared minus 1. This one might seem a little tricky, but it's really not. We recognize that there is no bx term. There's x squared and there's the constant, which means we've got to be looking at the difference of squares. So we identify what's being squared to give us that first one and what's being squared to give us the second one. Well, to get x squared, I know there's got to be an x involved. And what do I multiply by itself to get 16? 4. So my a here is 4x. Okay. Now b is whatever I multiply by itself to get 1. Well, 1 times 1 gives me 1. So this one's going to factor 4x plus 1, 4x minus 1. And there we go. It's factored. Next up, I've got 25 minus x squared. Now this one seems backwards, but that's okay. Okay, I still have x squared and a constant and no bx term. So I want to identify what my a and b are. A is whatever I multiply by itself to get that first one. In this case, 25. Well, 5 times itself gives me 25. And b is whatever I multiply by itself to get that second one. Well, x times itself gives me x squared. So this one factors 5 plus x, 5 minus x. And there we go. Okay, last one here, I have 100x squared minus 81. Okay, now this one seems a little tricky, and we might want to look for a GCF. Okay, is there something that divides both 100 and 81? Unfortunately, this time there isn't. But we can still recognize that there's an x squared term and there's a constant term, but there's no bx. So we need to look for what is a and what's b. So what's being squared to give me 100x? 10x times 10x gives me 100x squared. What's being squared to give me 81? 9 times 9 gives me 81. So this one's going to factor 10x plus 9, 10x minus 9. Okay, and please excuse that they're not all on the same line. They should be. These two are being multiplied together. Okay, so we have difference of squares. If we recognize that we have an x squared term and a constant term and no bx term, we can factor it a plus b, a minus b. We looked at factoring a whole bunch of examples. Here we go. Where we have a GCF that we can bring out, or we may have to keep that coefficient of x squared in our original or in our final factoring. Okay. Then we looked at some regular old examples of factoring using this chart. Okay, now this chart will always work no matter what quadratic you're looking at. If it can be factored, it can be factored using this. These two numbers have to multiply to give you c. These two x terms have to multiply to give you that first term. If your c term is positive, your outers and your inners have to add to give you bx. and they're both going to have the sign as bx, the same sign as bx. If your c term is minus, your outers and your inners have to subtract to give you bx. Ones plus ones minus, and the larger outer or inner gets the same sign as bx. Now, guys, I want to point out, I said the same outer or inner gets the same sign as bx. It's not always going to be, it's not always going to be the larger number gets the same sign as bx. Now, I know in these examples that seems to have happened most of the time, but that will not always be the case. It's always the larger outer, where'd it go? The larger outer or inner gets the same sign as bx, and that's why we always check these to make sure that it works.